Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. The title of our article is In Vitro Evaluation of the Inhibitory Power of Trichoderma harzianum against pathogens that cause Anthracnose in Chile. Chile is one of the strategic communities in Indonesia which often causes social upheaval when there is an imbalance between supply and demand. Efforts to increase production continue to be carried out by all stakeholders in Indonesia, but constraints are often encountered, especially in plantation. Anthracnose attack on Chile is one obstacle that can be detrimental and even lead to crop failure. Calotatrichum species is a pathogenic fungus that causes anthracnose disease, which is very damaging in Indonesia. Anthracnose disease in Chile has caused economic losses in various countries in the tropics and subtropics. Most of these diseases are controlled by synthetic chemical pesticides. The problems are controllably fails or cannot save production optimally. Second, the emergence of Calotatrichum pathogen resistant to fungicides. Third, active ingredient of pesticides poison non-target organisms. Fourth, active ingredient of pesticides cause environmental pollution. And fifth, active ingredients disturb the health of operators and the public. For that, we need to strive for alternatives that are environmentally friendly but effectively suppress pathogens and save crops. One alternative with a high prospect is the use of biocontrol biological agents, namely fungi, Trichoderma harzianum. Role and mechanism of Trichoderma's biocontrol for pathogen from various publications. First, directly paralyzing pathogens. Second, produce enzymes and extracellular compounds that can inhibit the growth of pathogenic cells. Third, develop competitiveness for nutrition and species against pathogens. Fourth, produce secondary metabolites. They play a role in helping plant growth. As in general, experiments in the application of biocontrol agents in vivo are always preceded by in vitro experiments. But so far, it has not been studied how the mechanism of direct inhibition, especially in conditions where the mycelium fungi agent control and mycelium fungi pathogens are close to one another and overlap. For this reason, it is necessary to deepen studies on the performance of biocontrol agent inhibition of pathogens, especially when the two mycelia are touching or overlapping. This information is also important in preparing further in vivo testing for the control of pathogens in the plant canopy. This study aims to determine the inhibition of Trichoderma harzianum TGGR02 isolates again to Calotatrichum isolates that cause anthracnose disease in Chile in vitro, and the mechanism of suppression of T. harzianum in mycelium which overlaps with mycelium pathogen. Method: the first in vitro inhibition test. Pathogenic fungi and biological agent fungi are a collection of microbiology and biotechnology laboratories, Universitas Muhammadiyah Sidoarjo. The harzianum isolates All potential biological fungi again have been proven effective in controlling in vitro and in vivo on potato plants. All isolates were grown in PDR media for 10 days of incubation. Each culture was sampled to a 5 mm diameter and placed opposite each other as a dual culture with a 5-3 mm distance between the center of the propagules and 25 mm each from the edge of the petri dish. This method was repeated 5 times with each monoculture accompanied by a 5 mm propagule placed in the middle of a petri dish. The inhibitory capacity of biological agent, again pathogen, and calculated using the IC formula. Microscopic observation. 2 weeks after the last observation, from the area where there was an overlap between the pathogenic mycelium fungi and the biocontrol fungi mycelium, was sampled with an ozone needle and placed on top of the glass object in exactly 1 drop that had distilled water. After being pressed gently and flattened, the object is covered with a glass cover. Observation were carried out under microscope with a magnification of 400 times to determine hifal conditions that overlap between pathogen and biological agent. Results. First, in vitro inhibition test. Based on observation of the growth of the biological agent colonies and both pathogenic isolate, both monoculture and dual culture, the percentage of T. harzianum inhibition was obtained for both pathogen as shown in Table 1. The inhibition T. harzianum against T. capsicum began to appear at 4.8 and has grown to reach 64.2%. While the inhibition of this biocontrol agent C. Gliosporoides start from 24 HAI with the value inhibition relative to inhibitory value agent against C. capsicum with 10% and become 65% at 168 HAI. Evidence of inhibition colony of both pathogens by their respective biocontrol agencies is shown in Figure 2. This is microscopic observation. Figure 2 shows destruction of C. capsicum hyper by T. harzianum. Look, pathogenic hyper marked GCS appear to be collapsed like fragmented. Meanwhile, Trichoderma hyper appeared intact. Figure 3 show the destruction of C. Gliosporoides hyper by T. harzianum. Look, pathogenic hyper marked CGL appear to to be collapsed like fragmented. Meanwhile, Trichoderma hypa appeared intact. The inhibition T harzianum fungi against C. capsicum and C. Gliosporoides is not the same based on the initial time, but the same at the end of the observation. Two different isolates showed different resistance performance against construction fungi in vitro. However, the inhibition that ranges 64 until 65% in Anthracnose pathogen in chilies is potentially effective in controlling pathogen. Trichoderma species has the ability to more quickly utilize space and nutrient with pathogen, so that this biocontrol agent has a competitive advantage. The results of the study are in line and supported by previous research results. The harzianum produces chitinolytic compound that can damage the pathogen cell wall, antibiotic compound against pathogenic colony. Some extracellular enzymes play a role in the mechanism of Trichoderma mycoparasitism, which cause damage to cell wall of pathogenic fungi. The broken Cholestatrichum cell wall can be used by the activity of the extracellular proteinase enzyme produced by T. harzianum. The biocontrol mechanism of T. harzianum in both Anthracnose pathogen in this experiment from the beginning to the end of the observation was carried out in the form of competition to gain control of space and nutrition. In conclusion, the biological agent of Trichoderma harzianum isolate TCGCR02 was able to inhibit the growth of Cholestatrichum capsicum colony by 64.2% and inhibit C. Gliosporoides by 65%. Microscopically, it appears that almost all the walls of the C. capsicum and C. Gliosporoides hypae are damaged as a consequence of the influence of the T. harzianum TCGCR02 hypae that are overlapping with hyperpathogens. Finally, the author thanks to the Ministry of Research and Technology for the Higher Education Applied Research (PTUPT) grant that he gave so that this article can be compiled. Thank you. Assalamualaikum warahmatullahi wabarakatuh.